and we are at question 8. Alright. So at question 8 they say a decoration lamp outfit consists of 16 lamps all connected in series. Like that's the lights that we use on Christmas trees or fairy lights. Right? So they're all connected in series with one another. Not all of them, some types. Okay, all connected in series. It is used on a 240 main supply. The current taken from the mains is 0.5 amperes. Okay, info table. So they say that the resistance, whatever it is 16 times x, or 16 whatever, because it's 16 of the same, 16 identical lamps. Then they say the volts is 240, and they say the current is 0.5. Okay. Now they say calculate the potential difference across the terminals of each lamp, meaning the volts for each lamp. Okay, so if we have, I'm not going to draw 60 now. Okay, let's say I'm going to draw that 4. The terminals is the end points, the beginning and end points, and they want the volts, the potential difference for each lamp. Now, since they are connected in series, it's like you having 16 subjects a day. Okay, so you have to divide your sandwiches into 16. Your total sandwiches, okay, the volts for one lamp, the volts for x, your total sandwiches is 240, and there is 16 light bulbs. There's 16 light bulbs. Well, the answer is 15. Okay, 15 volts. Okay, so each light bulb is 15 volts. That is 8A. 8B, they ask, what is the resistance of one lamp? Okay, now you could have done this in one of two ways. You could either have looked at one lamp. Okay, so the scenario for one lamp, or you could have looked at the total circuit. Okay, can I see who looked at one lamp? Okay, let's see. So for one lamp, what is the resistance we want to get? What is the current that passes through there? 0.5. And what is the volts for one lamp? 15. We just got that. Right, so we have resistance is volts over current. Whose law is that? Ohm's law. And can someone for a lollipop tell me Ohm's law in words? Without writing back the field. Okay, so it says the potential difference across the conductor is directly proportional to the current through the conductor at a constant temperature. Okay, so let's just give that one a moment. So in your Ohm's law formula, you have R is V over I. Then you fill in at V is 15. The current is 0.5. And then you get the resistance to be 30 what? Ohms. Okay. Then on the right hand side, so there where I say total current, okay, our info table there. We want to know the resistance. Okay, but next to the resistance, we said, because if we look at the total current, right, then we must look at the total resistance. So if one resistor we said is X, and there's 16 light bulbs, resistors, then there at R we need to fill in 16X. So next to the question mark, you fill in 16X. Then the current is still 0.5 because the current goes through all of them. And the voltage is 240. The total volts. Right. So then your formula would be R is V over I. At R you fill in 16X. At the volts you fill in 240. And at the current you fill in 0.5. Okay. And then to get X, you have to type in your calculator 240 divided by 0.5 times 16. 30. Things not go, yes, let's keep going. 30 ohms. Okay, so you could have done it in two ways. So with this whole chapter, there will always be, not always, most of the time be more than one memo, more than one way which you could have done this. Okay, so to not lose your head and track of what you are doing, info table, info table, info table. Give yourself a heading. Now I'm looking at one lamp, so my info table must fit with one lamp. Okay, I'm looking at the whole circuit, I'm looking at everything, my info table must fit that. Okay, otherwise you will put the whole circuit thing with one lamp thing and then your answer is wrong. Info table, info table, info table. Alright, question 9, can I go away there? Okay, we are looking at question 9. It says a 40 ohm and a 20 ohm resistor are joined in series and a potential difference of 12 volts is applied across the ends of the combination. Okay, so that's basically saying that you have two resistors in series, 40, 20, and the volts given to them is 12 volts. Now they ask that question 9a. Calculate the current passing through each resistor. Okay, now before I do that, I consider my diagram. Here goes my little main. The whole current must pass through there. The whole current must pass through there. Okay, so I know that the total current passes through there and the total current passes through there. Okay, and that's basically what they ask. What is the total current? So if they ask the total current, then I must have the total volts and the total resistance. I can't just look at the 40 and then at the 20. Okay, they won't have different currents passes through them. They'll have the same current.
So how do you know they're asking for total current?
Okay, so I drew the circuit. Then they said, calculate the current passing through each resistor. So I checked. Okay, what's going through this resistor? Oh, it's the total current. What is passing through this? The total current. That's why I say always draw your circuit. Okay, oh, you weren't here last year. Always draw it. If you don't draw it, because your next bit of homework is going to get more intense. If you don't draw it, what am I going to do? Out. Do it again. Draw your circuit. Even if you look at the homework on the next page, page 11, I give you the circuits. You are going to redraw it for yourself so that you can visualize, so that you can see what is going on here. Okay. Sorry? Okay, so through each resistor, what is going through this one? Oh, it's the total current. Through this one, total current. So it's the same current they're asking. So the total volts is 12 and the total resistance, Montley? 80. How did you get to 60?
40 plus 16.
Thank you very much. Okay, so our formula is this one. Let's see now for a lollipop. Anyone? Ohm's law in words.
The potential difference.
Okay, the potential difference in a circuit is directly proportional to the current.
Yes, Bukamuso? Can you what? Wait, yes. Anyone else? Across a conductor. Is
proportional to the current of the circuit
through the conductor. All right. And if losers, not losers. Jealousy makes you nasty, not losers make you nasty. Jealousy makes you nasty. Alright, that is 12, that is the current. Then the current is at the bottom. We don't want it at the bottom, we want it at the top. Yeah, 0.2 amperes. Alright. Then at question 9b they ask, what is the potential difference across the terminals of each resistor? Meaning, how much volts does each one get? Okay, so if I look at my sandwiches, I have 12 sandwiches. When I plan for the day, I have the 40 and the 20. So I have to divide my sandwiches into two. One here and one there. Okay, so we want specifically through each resistor. Okay, so now I have to specify, am I looking at first at the 40, first at the 20? Let's see. If I look first at the 20 ohm resistor, info table. Did I say 20?
Yes.
Oh, yeah, sorry. Do what I do, not what I say. In life. Alright, the resistor volts current. Dimakaso, what is the resistor? It's a trick question. It's 40. Okay, the volts is what we want to get. It's potential difference. What is the current or the fill way? Okay, 0.2. Because we just saw at the previous question that the total current passes through there and the total current is 0.2. Alright, resistance is volts over current. Clono, give me Ohm's law in words.
The potential difference.
How do you put a voltmeter?
Because the conductor is directly proportional
To the
to the current through the conductor.
at
It's temperature something. Constant temperature.
and a constant temperature. No way. Alright. Now the volts that we want to have is at the top. It's fine, we're happy with that. So we're going to take the 0.2 to the other side and multiply it, and you get that to be 8 volts. Yeah. 8 divided by 40 divided by 5. Okay. So when we look at our situation here, we had 12 sandwiches. The 48 used 8 of our 12 sandwiches. Without doing any big calculation, tell us what is the volts through the 20 ohm resistor?
I would say it's 4.
Why would you say that?
Because
Ma'am,
20 times 0.
No, but I don't want you to do a calculation like that. I want to use your knowledge of circuits there. We want to know of the 12 sandwiches, how much is used there?
So,
Of the
you subtract
yes, 12 minus 8 gives you 4. Now, ma'am, I know what to do, so why can't I do my long calculation? They can ask you or want you to use this answer in a question without giving you marks for calculating it. You have to know that concept of, okay, if we have total of 12s and we use 8 there, what do we have left there? So this calculation in grade 11 will count no marks. Okay, because it's something that you must know and then be able to use. Okay, so that is, yes, you can calculate it, then you'll do an extra calculation for yourself. But if you know the concept, then you can just use it. Yes?
Ma'am, why did you write V20 there?
Because it's the volts for the 20 ohm resistor. If the resistor had a name, let's say this one's name was A, then I would have said the volts for A. So it's just its name, it's just a subscript. Oh, I can use 20 ohms. I'm just lazy. I just stopped at 20. Okay. Right, then C. They say the quantity of charge which passes through each resistor in a quarter of an hour. Give me any piece of information that I can put in my info table there. What do they ask? What information do they give me? Like, where do I put my question mark? They're looking, what's the symbol for charge? That's a unit. What is the symbol? That's the symbol for Coulomb. Q. All right. Botumelu, what other piece of information do they give us there? Say again? So I just couldn't hear. Okay, the time. Yes, what do they say? Quarter of an hour. Do we work in hours? And how are we going to get a quarter of an hour? 2 seconds. Then we have minutes. How many seconds are there in 1 minute? How many seconds are there in 1 minute? Times 60 times 60. Okay, and that gives you 800? 900, yes.
You could have just said 15 though.
It's 15
minutes,
15 minutes times 60.
Yeah, that's true. But I wondered if everyone knew 15 minutes is a quarter of an hour. All right, Fatima, now what?
We have quantity of charge is equal.
Well, yeah, okay, so you said, they ask Q, I went let's go to a formula that fits with that. Okay, Q is?
I times.
Okay, so I want I. What is I? And that is? They said the quantity of charge which passes through each resistor in a quarter of an hour. We got at the first question, the question was, what is the current through each resistor? We got that to be 0.2. So we use that answer here. And remember, from one question to the next, we work with your mistake. Okay. So we have 0.2 and the time is 900. 180 what? Coulombs. Okay. So, back to your notes. Yes.
We're no longer writing out of 100 paper.
Oh, yes, thank you for saying that. So, grade 11's. No. Like I'm standing here today, I'm still not sure what you write on and how you long. Where you write. What I received there yesterday comes from Bloemfontein. It's also in our original planning for the year. Then they send other planning. Then they send other planning again. Back to 150. Then because the question paper comes from the department, when they send the timetable to us, when we should write physical sciences, it shows that we are writing 2 hours instead of 3 hours. And the one subject advisor, we have 2 for physical sciences, says we write 3 hours. The one says we write 2 hours. So I am still as confused as you guys, but I am saying let's rather be over-prepared. Okay? Then we say 2 hours, this term's work, and then we can't answer the exam. Okay, so 3 hours will be enough. 150 marks. I'm also printing that paper for you, so those of you that don't have data or whatever. and it tells you what you write on. So it's everything of first term and second term. You can see there's still 2 chapters that we need to do for the second term. Okay, not this chapter, 2 more. Okay, now, if we don't finish, for whatever reason, we don't get to the last bit of work that we should get, then the morning that I receive the question paper, I will look at the question paper and say, skip this question, skip this question, skip this question. Okay, but we're going to try to get there. We're going to push. But if we don't get there, then that's what we will do.
Ma'am, will Newton's always take like a lot of money?
Always. Okay, if you look, I just want to see. Okay, if you look there, of the 150 marks, 35 marks goes to Newton's law, 23 goes to electrostatics, and 28 goes to circuits. So let's get to past paper so that we can focus on circuits. All right, and then we still need to do 2 more chapters. Chemistry, atoms and forces, intermolecular forces. All right, let's get going. So, let's just look at parallel resistors again. So there you can see your current goes do. So everyone must pass through that ammeter. So that ammeter measures the total current. Okay. Then you see it splits up. Some can go there, some can go there, some can go there, like I showed you in the video this morning. Okay, so the current splits up into 3. So if it is in parallels, like you have a choice. You can either do accounting or geography or tourism, whatever. Okay, so you have a choice between 3 subjects. Okay, so what happens is that the sum of the current through the branches, we call this branches, is equal to the main current. So the current splits up, or a fancy way of saying that is resistors in parallel are current dividers. They split up the current, they divide the current. Okay. Then if we look at the volts, okay, the sandwiches. Let's say for this day you get 10 sandwiches. Okay. Now, Bukumuso, we're going to say you walk here and you chose accounting. Before accounting, how many sandwiches do you have? After? Accounting, easy peasy, you don't need any energy. Zero. Why? Because you go directly home where you get 10 more sandwiches. So if you take accounting, you have 10 sandwiches. Karabu, let's say you chose, what was the other option? Geography. Here you walk. Before geography, how many do you have? After? Hukum? You're going back home. So you have 10 sandwiches. Then, help me with your name again. Zeno. Zeno. I need to write this down for myself. Sinom. S-I-N-O-M-T-H-A. Okay. Sinomta, you chose tourism. Okay, here you walk. Before tourism, how many sandwiches? Afterwards? Hukum? Okay. So you can see that if it's in parallel, then the voltage does not need to split up because it's different. Can you see I asked different people? It's different charges going through different places. So the voltage is the same for all of them. Okay, so the potential difference, the volts over each branch is equal to the potential difference over the whole circuit. Alright, and then because we can't say I have accounting and geography and tourism, okay, I don't have 3 subjects, I only have 1. So we can't add the resistors normally. Okay, so the total resistance in parallel, you add a bit weird, you add 1 over R parallel is 1 over R1 plus 1 over R2. Repeat. You don't say I have accounting and geography and tourism. You don't have 3 subjects. So we can't say the total resistance for the circuit is this one plus this one plus this one. You can't do that. So that is why we have a weird formula. You have to add them different way. Okay, so let's look at circuit. It says there, or it shows there, that you have 6 sandwiches. There you walk. Everyone must pass through that ammeter. So that ammeter measures the total current. Then your current splits up. You either have one period of tourism, or a double science, or one business. Okay, right, so remember, this might not be you, this is life. And what we assume will happen is that most people will go through there because it's the easiest. Then the least amount of people will go through this because why in your life will you have to take a double science? Okay, so we think the biggest current will be here and the smallest current will be here, and this must be somewhere in the middle. But what we do know, whether you choose business or tourism or science, that your number of sandwiches will be the same. You can't change that. All right. Sorry. Now they ask, calculate the reading on the ammeter in the circuit. Okay, now I want to split this page up in the middle. But you can also do, there's a bit of space, you can add more lines at the bottom as well. Okay. The reading on the ammeter in the circuit, we saw that the ammeter measures the total current. Okay, so they want the total current. So for that we need the total resistance and the total volts. Total volts, easy peasy, that is 6. Bontley, the total resistance, can I say 2 plus 6 plus 6 plus 4 gives me 18? No, what are we going to say?
We're going to say 1 over RT is equal to 1 over 2 plus 1 over 6 plus 1 over 6 plus 1 over 4.
No.
1 over 12.
1 over 12, why? These two answers here is to one another. So you add them normally. 1 over 12 plus 1 over 4. Alright, I'm going to zoom in on the left hand side. Okay, now you can type that into your calculator or you can use your brain that you received. Yes, 6 plus 1 plus 3 is 10. 10 over 12. That's the same as 5 over 6. That's like in exam. 1 plus 1. Just checking if it's still 2. Did you know some universities does not allow you to use a calculator in mathematics? Because you need to use this thing here. That is why I push you guys to use your brain. You have it. You have the knowledge in there. The more you use your calculator, the less you practice your brain and the less confidence you have in your brain. Yes, 5 over 6, 1 over 10, same. But remember, that is 1 over R parallel, and we don't want that, we want R parallel. So you swap them around. 6 over 5, and that gives you 1.2 ohms. Dimakaso, how do you know you're more or less on the correct path with what we are doing there? Yes? Yes, the 1.2 is smaller than your smallest one in parallel. So is 1.2 smaller than 2? Yes, it is. So you think you're on the correct path. Alright, so that is the total resistance in the circuit, but they ask for the total current. Okay, Ohm's law, go for it, Flonu.
The potential difference across the conductor is directly proportional to direct. I don't know.
The total the potential difference across the conductor is directly proportional to the current through the conductor at a temperature. 5 what? Ampere. Okay, so that's thinking. It's not correct if I say that, but that's thinking that there's 5 charges, 5 people moving through the circuit. It's not correct. There's not 5 electrons, but you can think of it as.